Welcome to the virtual tutor series on core mathematics for senior high schools. In this lesson, we cover factorization of algebraic expressions. For a better appreciation of this lesson, I highly recommend that you watch our previous lessons on algebraic expressions if you haven't done so yet. Now back to today's lesson. Factorization of algebraic expressions. We will learn how to factorize the following types of algebraic expressions. Number 1. An expression that contains common factors. Number 2. Method of grouping. Number 3. Difference of two squares. Number 4. Quadratic trinomials. And number 5. Quadratic trinomials with two variables. Now, let's see how each expression type can be factorized. Expression type 1. Common factors. Given the expression AB plus AC, A is a common factor to the terms AB and AC. To factorize an expression of this nature, we first find the highest common factor, or HCF, of all the terms. Place the HCF, or highest common factor, outside the bracket and enclose the quotient within the brackets. To demonstrate this, let's go back to our original expression, AB plus AC. The HCF of AB and AC is A. So we bring A outside. Open the bracket. AB divided by A is B, and AC divided by A is C. So we put B plus C inside, then close the bracket. It is important to note that factorization is the reverse of expansion. Thus, whereas in expansion we remove brackets, in factorization we compress the expression by introducing brackets, as observed in this illustration. Now, let's consider some examples. Factorize completely. Solution. Example 1. 5xy plus 10ny. The first step is to find the HCF. The HCF of 5xy and 10ny is 5y. So let's bring 5y outside of the bracket. Then open the bracket. 5xy divided by 5y is x, and 10ny divided by 5y is 2n. Therefore, the quotient is x plus 2n. Bracket closed. So that's it for example 1. Let's move on to example 2. 6a plus 4b. The HCF of 6a and 4b is 2. And so we bring 2 out and put the quotient 3a plus 2b in brackets. Good. Let's now consider factorization type 2, method of grouping. Sometimes we are given an expression with 4 terms, like a square plus ab plus ac plus bc. We factorize such expressions by putting the first 2 and last 2 terms in brackets. Factorize each group separately and then put the factors in each group in bracket and set it against the common term in the bracket. Don't worry if things are not clear yet. With some few illustrations, you should be good to go. So let's try to factorize the expression a square plus ab plus ac plus bc using these steps. Step number 1 is to put the first 2 and last 2 terms in bracket. Step number 2 is to factorize each group separately. The common factor of a square and ab is a. So the first group factorizes into a into bracket a plus b bracket closed. The common factor of AC and BC is C. So the second group factorizes into C into bracket A plus B bracket closed. Now, we have A plus B to be common to both groups. Therefore, step 3 is to put the factors in bracket and set it against A plus B. So we have into bracket A plus C bracket closed as against into bracket A plus B bracket closed. Let's work a few examples. Factorize completely. Solution. Example 1. 2xy minus 6pq minus 3py plus 4qx. For the sake of simplicity, let's rearrange the expression by bringing 4qx close to 2xy. Now, the first step is to put the first 2 and last 2 terms in bracket. The second step is to factorize each group separately. The common factor for 2xy and 4qx is 2x. So the first group factorizes into 2xy into bracket y plus 2q bracket close. The common factor for 6pq and negative 3py is negative 3p. So the second group factorizes into negative 3p into bracket 2q plus y bracket closed. The third step is to put the factors in each groups in bracket and set it against the common term in the bracket. So we have into bracket 2x minus 3p bracket closed as against into bracket y plus 2q bracket closed. Example 2. 3a squared plus 2ab minus 12ac minus 8bc. Step 1. We put the first two and last two terms in bracket. Step 2. We factorize each group. So for the first group, we have a into bracket 3a plus 2b, bracket closed. And for the second group, we have negative 4c into bracket 3a plus 2b, bracket closed. Since 3a plus 2b is common to each group, we put the factors in bracket and set it against 3a plus 2b. That is into bracket a minus 4c, bracket closed, against into bracket 3a plus 2b, bracket closed. Nice. I hope you now know how to factorize algebraic expressions using the method of grouping. Now proceed to the factorization of the difference of two squares. In the previous lesson, we learned how to expand the product of two binomials in the form of difference of two squares. The output of such expansion was in the form a squared minus b squared. We can factorize or reverse the expression using the following steps. Step 1. Bring common factor out, if any. Step 2. Find the square root of the terms. Step 3. Put the difference between the roots in bracket. Step 4. Put the sum of the roots in bracket. And step 5. Express the product of steps 3 and 4. Again, don't worry at all if things look unclear now. Remember, the proof of the pudding is in the eating. So let's try to factorize the expression a squared minus b squared using these steps. Since there is no common factor, we skip the first step. Now, step 2 is to find the square roots of the terms. The square root of a squared is a, and the square root of b squared is b. So step 3 is to put the difference between a and b in bracket. And step 4 is to put the sum of a and b in bracket and set it against a minus b. Let's consider the following examples. Factorize completely. Solution. Example 1. 4 minus x squared. There is no common factor, so we skip the first step. 4 can be expressed as 2 squared. So the expression now becomes 2 squared minus s squared. For step 2, we find the square roots of 2 square and s square. The square root of 2 square is 2, and the square root of x square is x. So for step 3, we put the difference between 2 and x in bracket. For step 4, we put the sum of 2 and x in bracket. And for step 5, we express the product of the two binomials. Example 2. 36q square minus 49p square. Again, we skip the first step since there is no common factor. The square root of 36 is 6, and the square root of 49 is 7. So the expression can be rewritten as 6q all square minus 7p all square. Now we put the difference between 6q and 7p in bracket and put the sum of 6q and 7p in bracket and set them against each other. Example 3. 18x squared minus 98y squared. Step 1. The common factor of 18 and 98 is 2. So we bring 2 out. 18x squared divided by 2 is 9x squared. Negative 98y squared divided by 2 is negative 49y squared. Step 2. The square root of 9 is 3 and the square root of 49 is 7. So we have 2 out with a big bracket opened. 3x all square minus 7y all square and big bracket closed. We have 2 out again. We put the difference between 3x and 7y in bracket and set it against the sum of 3x and 7y. Well done. This is the end of today's lesson. In our next lesson, we will cover factorization of quadratic trinomials. Please kindly like, share, and subscribe to the TVTS YouTube channel in order to receive notification on future videos. Thank you for watching and see you in our next video lessons.